opening up the river for the mill here. Probably take a bit of work to heat this place. Isn't this lovely? We got a few things to work on in this place. Changing all the beltings, fixing the wheels, getting it properly lubricated. And then we'll be working on that elevator over there. So I'm up in the attic here at the mill and resurfacing these friction wheels, which we made a little lathe and we turned them down and then built up the right diameters, peeled off there was double layers of belting, trued both surfaces, and I'm now just retreading the whole surface. I'm using 2-inch long ring shanked, low profile stainless steel nails, and to get these traction belts in proper condition. They were one thing that when we rebuilt this whole section here, which I'll get better pictures later, the museum didn't want me to touch them, and of course it's been causing problems. You can see that I've beveled it off and got these at least these tracking properly, because these old wooden belts, they aren't exactly perfect. Anyway, we got it perfectly round. We got a single traction, and I'm nailing that up, and we'll run this in. So we've resurfaced these. This friction wheel has never been this smooth. There's no vibration anymore. I had added springs on the top of these bearing blocks so that they could shift before, and now this is running just so perfectly smooth. We're pretty happy with the whole thing. I'll get back here and sort of show you the mechanisms. So this whole outfit runs off of one turbine, comes up. You can see we've disconnected it, and we're running it on the frequency drive over here. Is that ever slow?
So if you look really closely, you can see above the two wheels spinning opposed to each other, that little blip, that's the cup holding the flour coming up the track from the basement of the building.
What do you see? Pretty fun, eh?
There's the cups coming up, bringing the flour up from the basement. So the wheel on the right, the belted wheel on the right, is tensioned against the other wheel that runs the line shaft with the scoops for the flour coming up from the sub-basement. This is the mechanism that runs it all. The jack built and installed. We have it running on an electric motor right now because the turbine isn't working. It's still winter.
Okay, we're running in the system after doing the friction belts. We're changing up new belts. We're running oilers in here. So we're running it off this motor here. Look at how smooth this baby is. I don't think it's run this smooth since brand new, and it might even be a little bit better. So we we completely constructed and engineered and designed, or I did, this mechanism to replace what was existing, which was in a terrible condition. Like, there's some of the parts that it used to look like. This is a fully automatic system now with oilers, thrust collars, and we should have no issues anymore. Pretty cool, actually. And this runs 2 elevators off of a line shaft. We did this one a few years ago, which is the other counter shaft to run the last elevator over here, which is the grain elevator, just running beautifully smooth. Anyway, a pretty cool thing to be working on. Very proud of it. This is Andrew, someone I've known for years and years and years. And it's his first time we've worked together in 30 friggin' years, eh, Andrew?
Yeah, well, we used to back in the early 80s.
Back in the early 80s, we worked together in the same cabinet shop. So, it's a small world. Working on this part next, or simultaneously. And of course, we have to disconnect it because this is powered off one of the main turbines. And it's directly connected, so we don't want to touch any of this stuff. We're not supposed to yet. It does need to be worked on. So we're going to disconnect it at the coupling hub here. Andrew is just slinging it so that shaft doesn't move. We have to do all of the belting and bearings in this. This one is not in operation, but as you can see, belting's pretty deteriorated. And so we're going to check the bearing arrangements up in here and before we cut and make new belts for that. So this one's not so much any mechanical, but we're rebuilding the whole elevator on that side. I'll show you that later. Okay, we've got a problem here, Houston. We've got the way that we're looking inside the grain elevator, and it's put together with these belts. This one's been broken for a while, and it's running into the side here, causing us problems. If this other belt breaks, we've lost the whole grain of elevator, and the whole belt system will drop down into the basement. Okay, you can see that there's hardly any strength in this connection. It's reduced the power of this belt to just the width of 2 little belts here. One's already broken, as I said, right there. The end of that belt is broken, and it's been broken for a while because you can see there's flour all over it. So we've been running on one belt, and if this breaks, we lose everything, and this will all bind up inside the chutes. And it looks like an overlap, which is causing other issues. So anyway, I just wanted to video this before we actually fix it. Luckily, there was a couple pieces of 5-inch with this belt is 5-inch, and none of that was ordered. Okay, although this one may look somewhat in good condition, it's not. First of all, there's a piece of belting missing between here and here, which is snagging. And you can see that it's stretched to a point that there's the original width. And so you can even see the fractures in the belting, eh? It's gonna go. This, I think the only reason they use these is because they didn't have a way to get a pin in, but we figured out a way to do that. We're going to do clipper laces, which are permanent, and they'll last the length of this belt. Okay, so we're lifting this counter shaft to get this belt replaced, which goes up to there, and we've opened up, and there is no lubrication at all in these. These obviously have not been done for a long time. I'll show you a video of that. We're gonna rig it from here so that, because there's no other way to adjust this belt and there's no way to roll it in place. So I'll show you what we have to do some work to the interior of these. They have to be cleaned. They're not been maintained at all. So these two belts, we have a belt that's coming from here over to this drive, which this comes off of a big 60 horsepower turbine. It goes to this counter shaft, which we have to work on. And then it's going to go to this counter shaft, which we're working on next. And we got to hoist that up to get this belt, which goes up to a machine upstairs. There's a bit of work to do there. I'll give you a look at the sort of where the whole thing is. You can sort of see this area is blocked off. We don't normally, most people don't get to come down into here. Anyway, gonna be fun today. Of course, it's freezing down here because we're actually down just above the river. You can hear the river in the background. Anyway, should be fun. Okay, I just scraped all the crud off of this, got access to the oiling cap, which I'll show you how covered that is. That's just, we can barely see them anymore. These are your drain plugs. These have, the tire sump pit is not even got oil, a little bit of oil, but you can see these rings right here are supposed to draw oil up into the bearing. This is the bearings, and so we gotta service those, which means we have to unbolt these, lift them, so we can get this belt off, and then I've got new oil to lubricate these. When you see the oil is all dirty, and it's causing all kinds of problems. Okay, so we're clean, so we're now adding it to this level here. That's our, just pour it in the side there. This is how much oil, that's a liter. This is how low the oil was. It's probably down 2 liters. Andrew, that they didn't even come up the sight hole yet. That's 1 liter added.
I wonder if my wife's got the other liter in her car.
So this is a nice little babbit bearing. It's self-aligning here. This is the babbit bearing portion. You can see the little rings. Do you see the little rings here? They roll around and bring oil up onto the shaft as the rotation out of this sump. So we're supposed to be at this is supposed to be to that level, right? So this thing, I don't think had oil in it for probably 70 years. Been working on this machine here. This is a grinder running off one of the other turbines. So we've run a new belt from the counter in the basement, the counter shaft in the basement. We rebuilt this counter shaft, which was all seized. A couple of the gimbals that lock this in place were broken off. Just everything was seized, hard grease. We've re-greased it. There was one of the grease caps was missing, so I made one out of wood. And then we rebuilt the entire shaft. That was leaning over. The whole shaft was then replaced. All bronze bearings, little spacers, see, right? See the little bronze spacers. Put new bronze bushings in the shaft, a new shaft, as well as this one down here. We're going to run buckets in that. I still need to make perhaps a binder for this, but we're almost ready. I'm almost ready to make a new belt now that we've got stuff tracking. Those are just old belts for length, because when we shift stuff around, right, the machine had shifted on the base, so we made these little blocks here to lock the machine in place from shifting, so that the everything's lined up. This part of the museum is on the main floor, and this This is a hopper for duck feed. I don't know if we have a, there might even be a, I think there's a container. So that's what that makes. It mills stuff for animal feed. At any rate, it hasn't probably, it didn't look like it had anything done. Here's the elevator that's being rebuilt. It had, all the buckets were bent and damaged. Some of the links were broken. In fact, some of the buckets were missing with improper numbers of links. That's been 2 to 3 days straightening these out and getting the links straight. So we're almost ready to put that back in position and then see if everything's tracking. Okay, so we're putting in the buckets now, and Andrew discovered how clever this little thing goes together. And if you look closely, you're going to see there's a little groove on that side, very subtle, and none on that side. So watch how these links go together. You tip them and you slide it out, and it has to go in on that groove side. Show them, Andrew, it doesn't go in the other way. It will not go in the other way. There's how those links go together. Will not go together that way. Very subtle. You surely couldn't see it when it was a rusty mess filled with stuff, but we got to feed this now up through and get this elevator working. One window. So we're going to cut a window into our grain elevator and let the people see. What do you think? So they can replace. So we'll mount this into the grain elevator, and then this will just hold the glass in if they ever have to replace it. 2 screws. Okay, so we're having problems with the elevator having a kink here. And so Andrew's got the slick, and he's just cleaning up the mortise, which was really badly done with a chainsaw. There was a bit of a kink in that, and that was causing a bunch of vibration. So we ran a string on it, it was out, right? And nothing wrong with a real chisel, eh, Andrew?
This old thing?
Yeah, this old thing is great. How else are you going to get in there and do your work? So, show us that chisel face on there, Andrew. Oh yeah, that's a chisel, man. Yeah. Found the major culprit with all the noise, and we did a bunch of work and got this cleaned up. It looks like this timber, as you can see, a lot of twist in it. There's even a crack over here, but the twist in that timber shifted the thing over and put a kink in that, and so the buckets were just rattling like crazy. 10 times more quiet and definitely smooth. How we can tell how smooth everything is because I'm running this all on a variable frequency drive. We've hooked up a motor downstairs to the counter shaft, and it's the first time we've had this running since we adjusted. It looks like it's running just beautifully. You can hear the noise you're hearing are the grinding plates in there, and the little clip is where the joint is in the belt. And this thing is just running beautifully. They never could see the grain elevator buckets before, and now we put in a little window so you can actually see the grain elevator buckets coming up and down in the grain elevator. So this is running way better. So the grinding stuff gets blown out of these two grinding plates, and then it gets dumped into bags over here, right? And then you can see the grain elevators come around and pick it up. Isn't that cool? So I'll show you the counter shaft downstairs. Okay, so here we are in the sub basement. We rebuilt this whole counter shaft. If you remember, we redid all of these bearing blocks. So what we're doing here is we're just running it off the variable frequency drive onto this. There's a little shake on that, eh? But that's a big pulley. And that's going up to that machine there. This is connected to this other counter shaft over here. This counter shaft and that big pulley run back to this counter shaft, and then this is the turbine that transfers power to that counter shaft, and that's just disconnected. We're just running in the machine. And so once again, I'm running these in on my 110 volt variable frequency drives, which plug into a regular household current. So if you're looking to run any three-phase equipment up to 2 horsepower and all you've got is 110 volt single phase, give me a call. I'll have in stock 16 of these in 3 weeks, and we're running a promotion where you get a free extension kit for the first 30 orders. We have about 18 pre-ordered already, so can't say it'll last. This thing is beautiful. There's Andrew adjusting the speed. We can run this at what, 1 RPM? Go down to 5, Andrew. Is that 5 hertz? And look at this. A 110 volt thing is running a huge system at 1 revolution per minute. Okay, so this is the main drive wheel off of the 60 horsepower turbine. And this is a typical fix here, where they put a 4-inch in the center, and this makes it crowned. Problem with that is it reduces this 8-inch diameter wheel to a 4-inch traction plate, which this was slipping, and of course then the belt was tightened and it got worse and worse. So we're adding banding, belting on either side of that, and then we're going to retread that whole surface with the replacement belts. So we've replaced a bunch of these belts. We're going to use those to tread our new powertrain. And we can't really get this running yet. The reservoir which I'm standing on, this is the tank over top of the tank that holds all the water for the turbines. I'll show you that, is frozen solid. We're still waiting for that to thaw out, so I don't know if you can see down there, but that's a block of ice is what you're looking at there. We've got to get that to thaw out before we can run the turbines off of the river. Okay, and she's flowing pretty good. We got above freezing temperatures this whole week. Okay, so we've run belting on either side. You'll notice that I still have a slight crown here. So we're now going to tread with an 8-inch belt so that we get full power transmission. This never had it. It was really only running on the 4-inch as a crown. So there's still a little bit of crown, you can see. Now we'll get our traction and we'll nail this on, and then we'll make our belt for transmission. I'd repaired this belt a few years ago, and it had to be so tight because, well, there was a lot of resistance in the whole works, which is a lot better. So that is retreading the main drive belt. So I'm standing here on the dam for the Watson's Mill. This is the gristmill that we've been working in. Beautiful example of 1860s factory technology, which is very rare nowadays, at least in Canada. And this is an English design. These are the fir timbers that block off the levee. Boy, that's all Doug fir, right? But water levels should come up. We're looking at double-digit stuff this week, right? And this side doesn't usually have water coming down it. But so the turbines are in that sub-basement. We're working in the basement right here now. That's the first floor off of the riverbank. That's the second floor, and then our works are up in the attic. Beautiful example of technology that water powered, and I'm very grateful to be the one selected to rebuild this. So what you're looking at here is the concrete work which diverts the water into the reservoir tank, which then comes out the turbines at the river level, which is lower when the dam is held back. You can see the archway where the chute used to run through. That's been blocked off. And a few years ago, the whole building got repointed, which is hadn't been done in a while. And because this is in the river and is subject to freeze and thaw, it was starting to deteriorate. You'll notice that the window lintels are hand chiseled. I'll see if I can. So that portion right there is hand chiseled stonework. And this stonework, although rustic, is quite nice. The quins are nice and even, and just deadly straight. Look at how straight that building has stayed. It's just deadly straight. So just a magnificent example of Canadian industrial architecture. The entire complex includes the Dixon House, which was the owner's place. This is original 1860s as well. And that is now part of the museum block. So this whole complex, that's the carriage house where the offices are. There's the face of the museum on the street side. This whole thing now is an historical district, and we'll be in charge of future expansion. Talking about adding another carriage shed for modern facilities. But you can see on the front of the museum at ground level how much she drops down into the river, and just a fine example of great work. And once again, we're very grateful that we were selected to maintain this. And anyway, thanks for watching, guys. And I'll always document the work being performed here at the Watson's Mill in Manotick, Ontario, Canada.